This time we want to look at trigonal planar. Now we notice that the shape and the geometry can be different. So we can either have a trigonal planar and a trigonal planar, or we can have a trigonal planar and a bent. And the important thing here is this time we have 3 substituents. So you notice the example I have over here on the right. There are 3, 1, 2, 3, around this orange central atom. In this example, everybody has a bond, right? Everybody's got somebody hanging out at the end of the toothpick. So in this case, the shape is trigonal planar and the geometry is trigonal planar. Now, if you look at this example that I have right here, I notice there are 4 bonds present. However, what else do you notice? Well, I notice that there's still just 1, 2, 3 around the central atom. So even though this one has 4 bonds, it still is going to be a trigonal planar. Now, what happens if we look at this next one down here on this line? I need to find one that has a non-bonding pair. So let's start with a basic first. So I've got this one right here. We notice that it is trigonal planar because it's got 1, 2, 3 bonds. But what do I notice? I notice that only 2 of those bonds have a substituent on it. The third one has nothing. So in this case, we notice this is bent. And if you kind of hold it up at an angle and look at it, you see that it's bent right here. Now, just like in the one we did before, what if we have a double bond? Well, if we have a double bond, we still just come up with 3 places for substituents. But in this case, I only have 2 substituents. So again, this one is going to have a shape of trigonal planar, but it's going to have a geometry of bent again.